Hey everybody, welcome back to the Main Machinist channel. This is Jeremy here at Hiltz Machine Works, and we're working on a Volkswagen buggy engine today. This came out of my pipe frame buggy that some of you have seen on my social media. We're going to be doing a full, complete guide to a compression test on an air-cooled Volkswagen engine in this video. It's going to touch on some things that I feel are lacking in other compression test videos. And you can see it's cold here in my shop, which I'm going to explain the reason for that in just a moment. But before we get started, I'd like to just thank a man from Alaska named Neville. He had sent me down a flywheel locking tool for air-cooled Volkswagen out of his personal collection. It was very generous and very much appreciated. Thank you, Neville. Now, the reason why my heat is off is because we're going to do two compression tests on this engine. First, we're going to do a compression test with it stone cold, just as it is now. And before you do a compression test, make sure you revisit the valve adjustment and have a good valve adjustment on all 4 cylinders before we begin. Once we take the cold compression test, I'm going to open the bay door behind me. We're going to run this engine up to a full operating temperature, and then we're going to shut it off and get another reading with a hot reading of a compression test. That'll give us a little more information about the numbers, and we can talk more about that later. So let's get started. Now, the very first thing that I'm going to do is I'm going to remove the air cleaner assembly. Next, we're going to take the throttle, we're going to have it wide open, and I'm going to zip tie the throttle in the wide open position. Needs to be wide open throttle when we do our compression test. Now, by this time, hopefully you figured out you should have all the gas either drained out of the car or just disconnect the inlet line on the fuel pump and make sure the carburetor doesn't have any fuel in it, because we don't want that to influence the test, and we don't want to have, a flooding problem or anything like that going on. So we have the throttle wired wide open. You can see here that I've removed all 4 of the spark plugs, and we're going to leave them out while we perform the test. Now, there's no specific order you have to do this in. I'm just going to start 1, 2, 3, 4. Just like if I was doing my valve adjustment. And I'm going to take my compression tool. I'm going to thread that in there, and it doesn't have to be real tight. I just go finger tight enough that it makes the seal. And you'll know if it doesn't make a seal because your gauge won't go up. Now you can either have a friend crank the engine over, or if you have it on a stand like this that has a bell housing that the engine mounts on, there are a variety of ways you can do it. They also make a little remote starter device that they sell at Napa that makes it real easy. You have a trigger that you can use to crank over the engine while you're looking at it. Whichever way you choose to do it, there's one thing we're going to be looking for as we begin to crank. We want to see if the needle is very slow to get up to the top compression number, or if it gets up there relatively quickly. I'm going to let this crank over 5, 6 times maybe and just watch the reading. Then we're going to write it down. We're looking at 140 PSI on this cylinder, cylinder number 1. Let's go ahead and hit the release. We're going to try it again. And again, we're getting 140. So let's write that down in our book. Let's check cylinder number 2. I'm reading 155 on cylinder number 2. Second check. Almost 155, a little over, 157. We're just going to call it 155 on this one. Here we are at cylinder number 3. The fabled troubled cylinder that you read so much about the internet. That in some ways is overhyped. Okay, cylinder 3. We are right at 150. Second reading. Now we're here with cylinder number 4. $145. Double check it. We have 140 this time. We'll average that at 142. Now we're going to consult the Bentley manual to see what it has to say about compression numbers. You can find here on page 59 of the Orange Book, which covers the years that this engine started its life at, compression pressure should be 114 to 142 or 107 to 135, depending on the year. The wear limit is around 100 psi or 85 psi in the later ones. Now, they began to give these lower compression and detune these as the 70s went on as an attempt to help with emissions and things like that. And anyhow, I would go more likely with these numbers here. 114 to 142 with a wear limit of 100. Now you may be asking, wow, you got pretty good compression in that engine. And that's true. But my engine is also not a factory Volkswagen 1600 single port. It does have 87 millimeter slip-ins in it, which I'm not a big fan of, but it's what I had at the time when I got this buggy. And the heads actually came from a 1300 that I opened up on the Bridgeport mill to accept the larger barrels. So it's a little bit different. My buggy engine has higher compression than what you might expect to see on a typical air-cooled Volkswagen engine that's completely stock. Now you can see here, they don't want there to be more than 28 psi difference between the cylinders. A lot of other people will say that you shouldn't have more than 10% difference between the cylinders. Now, of course, if you start off at 135 or 150, 10% of that is a lot less than 28 psi. So Volkswagen actually allows you to have more than 10% variation between the cylinders, but a good healthy number to go by is the 10%. So look at our numbers. 155, 10% of that is 15. Our lowest is 140. So we're right at the 10% threshold on our cold test. Now let's start the engine, let it get up to temperature, and we're going to do the same procedure and check the numbers a second time. I'm set up here with the engine on the stand, with the bay door open. I have removed the zip tie from keeping the throttle wide open. We are going to run this without a air filter element on it for now. We're going to run it for about 15 minutes. And I have my Bosch plugs back in place. We're going to feed fuel out of this gas can. And because I don't have a thermostat in this engine, because it's strictly off-road, I have decided to close the flaps, and I'm going to leave the flaps closed for a couple minutes just to help let it warm up. And like I said, we'll let it get right up to a good operating temperature for about 15 minutes. We're going to take the test again. Okay, we're all warmed up. We're gonna start back at cylinder number 1. We're getting 150. And 145. We had 150 on the first reading, 145 on the second. We'll balance it out to 147. Cylinder 2. Right at 150 as well. Cylinder 3. Getting 155. Try her again. $155. Finally, we're at cylinder 4. Right at 150. Oh, my battery's running low. Getting right at 145 there, not quite 150. But if it doesn't crank over fast, you'll notice it affects the reading. We'll go ahead and go with the 145 and the 150, so we'll put her at 147. So comparing our numbers, cylinder 1 is +7, cylinder 2 was -5, cylinder 3 was +5, and cylinder 4 was +5. So what we find here is our average was 146 3/4, and we had about a 9% variation. On hot, our average was 149 3/4, and we had about a 5% variation. So what do these numbers mean? Let's take a look at these numbers again. So the Bentley manual gave us a tolerance of 114 to 142 with a wear limit of 100. Now obviously all of our numbers were much higher than the low end or the wear limit. We had actually most numbers above the maximum given by the Bentley manual, and like we said, that's because this engine has been a little bit modified. What I want to point out here before we get into cold versus hot is that when you're looking at these numbers, you'll almost never get an identical reading out of a cylinder. You saw when we did it, on some of them we'd have 147 and 150, or 145 and 150, when we did a test back to back. And part of the reason I did that was just to show you that these numbers are not set in stone. You're always going to have a plus or minus reading on your compression gauge. And the compression gauge itself probably has a tolerance. I looked for the one that I have, I didn't see, but I wouldn't be surprised if it was ±3 or something like that PSI. So the actual literal number that you get is not as important as whether it's within the range that it's calling for. Just like in the Bentley manual, you can have 125 PSI and that's okay. You can have 142 PSI, that's okay. But what they want to see is that they're all about the same. You had the 28 PSI variance allowed by Bentley, and then I tightened it up a little bit and said, you're really good if you're within 10%. And our numbers showed that. We had, as we just saw, a 9% variation when it was cold and a 5% variation when it was hot. Now, why did we do the cold test followed by the hot test? The reason I like to do that is establish a baseline with it cold and then see if anything changes drastically under the hot test, because obviously as the engine begins to warm up, things are changing, clearances are changing, there's expansion taking place with the heat. I have a forged moly piston in that engine. Actually, it's over there. The one behind me is a 40 horse. But the forged mollies tend to expand a little bit more than the cast pistons do. So I'm looking to see, was there a big change in the compression before and after? In our case, there wasn't, which is a good sign. Now, what if we had a drop-off, like a marked drop-off when it was hot? If it was at a certain number, say 140 when it was cold, and then when we took it hot, it was down to 120, 125. There could be something cracked, maybe a crack in the head. We've all seen cracks by the spark plug hole, different things like that, where when it's expanding, it's allowing some compression to escape. There could be something taking place there. You're never going to know exactly what's causing it just from taking the compression test, but if you see wild changes from cold to hot, that's basically telling you, yes, I should probably tear this down and inspect what's happening. If you only do a cold test or only do a hot test, you're not getting to see that change. You're not getting to examine it and look at whether things are changing from cold to hot or vice versa. And you want to have that data when you do a compression test, especially if you suspect something is wrong. The more data you can collect, the better. And keep it all tabulated like we did here on our chart. So what about the old idea of using oil to squirt into the cylinders and then taking an additional compression test reading to check for worn rings? While that does work pretty well on most conventional water-cooled engines like an inline configuration or a V configuration, we're going to see here in the Haynes manual, it explains. Mechanics frequently squirt oil into the cylinders and perform a second wet compression test on conventional engines. However, this type of test is not reliable on horizontally opposed engines. And the reason for that is pretty simple. Your cylinder is coming out, and when you squirt the oil in there, it tends to just go to the bottom side of the piston, and it doesn't seal the entire area of the cylinder where the rings are contacting. So it's not as accurate on this style of an engine. Now let's take a look at this engine I have here. This is a 40 horse engine that I picked up in a parts lot that I bought out, and it had been sitting outside for a long time, and I'm currently tearing this down to see if there's anything I can salvage out of it, because German parts are getting very difficult to find in some cases, especially on 1200 stuff. But anyway, whether it's a 40 horse, 1600, doesn't matter. This is going to serve the same purpose for our illustration. If you take your compression test and your numbers are low, especially if you have numbers low only on one side of the engine, on either 1.2 is low or 3.4 is low, you're going to want to check the head to barrel seal that takes place right in here. And when I say seal, we're not talking about a gasket like on a water-cooled car. These cylinders at the top of the barrel here, this surface seals inside the combustion chamber of the head. And many times people have a low number on their compression and they immediately think, oh, I need to tear this down and replace my rings. Then they reassemble the engine and they find out, man, are these rings not seating? I still don't have good compression. Something is happening. What may be happening is many of the budget builds, backyard builds, home builds do not properly surface the combustion chamber inside the head. Even some of the new aftermarket heads have a poorly done machining job on the head. And then, when the engine's assembled, you have a leak from the barrel to the head, and you're actually losing compression out of this area. Something you can do to check for that before you decide to tear your engine down, if you have a low compression number, get your engine up to a warm or hot operating condition, and then use Marvel Mystery Oil in the carburetor. Just pour it down the throat of the carburetor, let the engine stall itself out from it. Kind of basically flood it out with MMO. Wait several minutes and then restart the engine. You're going to want to do this in a very well ventilated area because you'll get a ton of white smoke out through the exhaust. But while that exhaust is pumping out the white smoke, you can visually attempt to look beneath the car. And it's hard to do if you have all the tin work in place. But you can kind of look up and through here to see if there's any white smoke coming from down underneath the pushrod area or up and around the tins. If there is, you probably have a leak from the barrel to the head. So don't always jump to the conclusion that it's the rings or a valve condition like worn valve guides that's causing low compression. There could be a problem that's very common to have a sealing problem in here, especially like I said with the home rebuild kind of situation. At the end of the day, if you have bad compression and it's not an obvious cause, you're probably going to have to tear down the engine to investigate. But I hope you learned something from watching this video. I think that we covered some things that you're not really seeing in other air-cooled Volkswagen videos. And let me know in the comments if you found this video helpful, if there's something else we could retouch on in greater depth, or other videos you'd like to see in the future. As always, thanks for watching. This is Jeremy, Hiltz Machine Works. See you next time.